we start this one once again, all we're doing is we add or subtract the like terms. We're combining the like terms. Like terms means they have the same term value. X squared is a term. It can only be added to other things that have an x squared. X is a term. It can only be added to things that have an x. Our digit can only be absorbed to other coefficients. So the only thing that changes on these is the coefficient part. So in this case, the x squared, I have a 5x squared plus 3x squared gives me an 8x squared. 3x squared doesn't have any counterpart, so it stays 3x squared. 4 plus 5 is 9. Over here, we had one term is a squared b cubed. We can only add it to other a squared b cubes. We have a term that's ab, and we have a unit here. So 7a squared b cubed is added to a negative 2a squared b cubed. We get 5a squared b cubed. AB has nothing to add to, stays AB. Think of AB plus 0. 1 plus 0 is 1, gives us 5a squared b cubed plus AB plus 1. Now this one, we have a c squared b cubed term, we have a c b cubed term, and we have 6. So 4c squared b cubed can only be added to what? The 7. So the 4 and the 7 are going to get added together. So I get 11c squared b cubed. The 2c b cubed term can only be added to the negative 4. So these two are added together, and positive 2 plus a negative 4 is a negative 2. So it's minus 2 cb cubed. Go add them together. 4 plus 7, 2 plus negative 4, and then we have plus 6 because there's nothing else. Any questions? Make more sense? Making more sense? This is what we're doing. Now there's another way to do this, and that you can either do it this way that I'm doing, which is perfectly fine. I'm not going to specify what, but there's also another way. It's called the column method. And what you do is you match each part with columns. Now notice we have x to the 4th terms, x squared terms, x term, a digit term, but over here we also have an x cubed term. And how do you write this? First of all, I write this. 2x to the 4th, and there's a 5 plus, we have a 5x to the 4th term like that. Then, so that kind of takes care of those terms. Then, notice, there's only one x, 7x, so we go 7x cubed. We have 7x cubed. Now, is there any x cubed term in the other one? No. So we leave a space there because there's no corresponding term. But up here at the top, I have minus 5x squared. Down at the bottom, I have minus 2x squared. And then we have our x term, plus 4x minus 2x. And then I have plus 5. And there's no corresponding term to the bottom here. But see how this worked. In the column, the x to the 4th terms are lining up. The x cubed terms are lining up. The x squared terms. Basically, you are lining up those particular terms in our column. So when we add them up, 2 plus 5 is 7x to the 4th. 0 plus 7 is 7x cubed. Negative 5 plus negative 2 is negative 7. Negative 5 plus negative 2 is a negative 7x squared. Positive 4 plus a negative 2 is positive 2x. 5 plus 0 is 5. This is just another way to do it. I mean, I had the way we showed at the beginning. This is a different way. I'm not sure if your book specifies. Yeah, starting number 16, they do ask you to do it by columns. They do ask you to do a section to add by columns this particular method. Okay? So let's practice one. Let's practice. So any questions on that, what we did? You basically write it so that each term is directly over its corresponding term from the other polynomial. All right, so let's practice one. Let's say we have 3x to the 7th plus 2x to the 5th minus 14x to the 4th plus 2x squared plus x minus 1 plus 4x to the 7th minus 8x to the 5th plus 4x to the 4th minus 8x cubed plus 2x minus 6. All right, so, no, it's not. Just line up the corresponding terms. The corresponding term should be one over the other. So basically, if you can... All right, let's look at this. So I start with my 3x term. 3x to the 7th. Is there an x to the 7th term in the other polynomial? Yes. Yes, 4x to the 7th. So we line them up. Now we're adding together. Next, I might say, well, I have an x to the 6th term. Do I have an x to the 6th term in the top polynomial? No. Do I have an x to the 6th term in the other polynomial? No. I can leave a space, but there's no need because there's no term there. So I'm going to go to the next one, which was plus 2x to the 5th. Is there an x to the 5th term in the other one? Minus 8x to the 5th. And notice how I cross them. Every time I use one, I cross them out just so I know I use them. I go next. I have an x. Corresponding match on the top, so I leave a blank space. Yes, sir.
Why did you go on the bottom first? How come we didn't put 2x first? I know.
Why didn't I put 2x where?
On the bottom. No, 2x. You put negative 8x cubed first. 2x squared.
We go in descending order, right? X cubed becomes before x squared. Remember, descending order is by exponents. So 7, 5, 4, 3. Now we're going to go to squares. I didn't polynomial. Start standard thing. So x squared. Next thing would be plus 2x squared. Do I have an x squared term in the other polynomial? No, and so I'm going to leave a dot plus x plus 2x minus 1 minus 6. Add them all up. 3 plus 7 is 7x to the 7th. 2 plus negative 8 is minus x to the 5th. Negative 14 plus a positive 4 is minus 10x to the 4th. Minus 8x cubed, because 0 plus 8x cubed. 2x squared plus 0 is 2x squared. X plus 2x is 3x. Negative 1 minus 6 is negative 7. Remember, we are adding. All of them are adding. So it's a 2 plus a negative 8. Negative 14 plus a 4. 0 plus a negative 8. Positive 2. Positive negative 1 plus a negative 6. All right, remember, this is adding. We are adding. In fact, when we do this method, we're always adding, which is why the next second we're going to talk about the additive inverse. Yes, ma'am. What 3x? Oh, 1x plus 2x is 3x. No, it was in this example. Our number was 1x. To subtract polynomials, we basically were going to add the first one to the additive inverse of the second. So we have to find the additive inverse of the second. We might recall from the very beginning of the year, additive inverse. Basically, x plus negative x equals 0. That's the additive inverse. 4 plus negative 4 is 0. That's what they mean by the additive inverse. Okay? So, when we take the additive inverse of a polynomial, basically what we're going to do is write negative 1 times negative 4x to the fourth plus 7x squared minus 3x plus 8. We're going to multiply everything by negative 1, which means you go like this. Negative 4 times negative 1 x to the fourth plus 7 times negative 1 x squared plus negative 3 times negative 1 x plus 8 times negative 1. Basically, every single term gets multiplied by negative 1. So it becomes negative 4 times negative 1 is positive 4x to the fourth plus 7 times negative 1. 7 times negative 1 becomes negative, so it's minus 7x squared. Negative 3 times negative 1 is a positive, so that becomes plus x. 8 times negative 1 becomes negative 8. Notice basically all the signs reverse. We went from negative 4, positive 4. Positive 7, negative 7. Negative 3, positive 3. Positive 8, negative 8. And if you were doing this way, your subtraction problem becomes a positive. Just like I went from minus 3, I went plus negative 3. That's basically what we're trying to do. We're trying to get rid of that subtraction sign, because in the end, you're always going to be adding the two polynomials together. The reason you take this additive inverse. So in your word bank, an additive inverse, the polynomial that when added to the given polynomial results in a sum of 0. So if I was going to make an example, I might say negative x cubed plus 2x plus 8. Its additive inverse would be positive x cubed minus 2x minus 8. That might be an example like that. So you need to make your own example on your word bank. Yes, ma'am.
So all you have to do is like change the negative. So if it's a negative, change it to a positive.
Basically, it's because they're always negative. Notice all of them, basically, we reverse their signs. And in the problem, you're going to make the subtraction a plus. Remember, we're trying to keep, instead of going x minus something, you're going to go x plus negative x. Is what? That's what it means by that when you subtract polynomials. This is what you have to do. You have to take the additive inverse and add them. The additive inverse and add them. So you're going to make your own example there. So if we had a problem when we subtract like this. So first of all, it becomes, so we have 5x squared plus 3x plus 2 plus. Well, since when it was a negative, it was a positive 2 and a positive 1. When we change this side to a positive, which basically we're going to multiply through that by that negative 1, this becomes negative 2x squared minus 1, like that, to take the additive inverse. We're multiplying by negative 1. Positive 2 times negative 1, negative 2. Positive 1 times negative 1, negative 1. Now we do what we did before. We were adding our polynomials. 5 plus a negative 2 is a what?
3.
Positive 3x squared. Is there anything on the other side for the 3x? 3x. 2, positive 2 plus a negative 1 is positive 1. So our answer would be 3x squared plus 3x plus 1. So you guys try the second one, please. You guys do the second one. Yes, ma'am.
So we only change one of the...
You change, Mary, it's the one that's after the minus sign that gets changed. The first one doesn't get changed. It's the one, the second term, the term you're subtracting is the one that gets changed because this subtraction will become positive. Basically, the idea is you are always adding, so this becomes plus the additive inverse of the other one. When I'm done. So again, we regroup them. 2 plus a negative 1 is a positive 1. 3 plus a positive 5 is an 8. There was no corresponding b term. 3 plus negative 4 plus positive 2 is negative 2. Questions? Now we are also going to do some of these by column method. Columns are useful for subtraction too. But you got to take that additive inverse first. So we do our inverse. So I get 4x cubed plus 2x squared minus 2x minus 3. That's the first part. It doesn't change. Plus, positive 2 becomes a negative 2x cubed. Negative 3 becomes a positive 3x squared. Becomes minus 2. Now you guys solve this using the column method, please. Everyone right now, solve that using the column method. Damn it. So when we made our things here, our columns, remember we left a blank here. We add them together. We get our answer on that. Shh. Everybody have this down. Again, part of your assignment tonight is to do these by column method. You have to. In some of them, they just ask you to evaluate. In some of them, it specifically says you're to do it by the column method. Because then you would not be following the instructions and doing the column method. Because you will be required on your test to do it by column method. And if you don't do it by the column method, it will be marked wrong. So you need to practice doing the column method. Alright, if you have problems that just say evaluate, you can do either one. You might find some are easier to do by columns, some might be easier to do other ways. Sometimes with very long polynomials, it's sometimes easier to do the column because you can make sure you're matching up everything. Shorter ones, like binomials and things like that, we probably aren't going to be using the column method. But for very large polynomials, 4, 5, 6 term polynomials, you might want to use that. All right, everybody got this part down? So your assignment. Now the classwork for you guys. We're doing 1 through 25 odd in the first section, and 1 through 40 by 3. So 1, 4, 7, and so on in the second section. The red one is only for the 10th graders because they're working on Casey. Homework tonight. Page 233, 2 through 26 even. Doing the evens. We did the odds and classwork evens. 3 through 42, divisible by 3. So 3, 6, 9 also. But also, 1, your parents are going to sign your quiz and you're going to bring it back to me. 2, you're going to correct your quiz, whichever ones you get wrong. If you get the ones right, you don't have to do those ones. The ones you got wrong, you correct it, you look at your notes, and you correct it on a separate sheet of paper. This is done on a separate sheet of paper. Like, so if you miss number 2, you do that one. And you make up a problem that is like that one and solve it. Alright? Shh. You have a lot of time to do. You should be able to finish your classwork and get started on this one. You guys, as a group, did not do very well on this last quiz. This is why we're doing this. You guys, you're not really learning the rules on this.
Can you give us that quiz?
I am going to give you back your quiz right now.